Okay, I'm Shane. I work at Abaja right now. We do AI, and we're building a platform to run AI models on. So if you're interested in that, come talk to me today. Completely unrelated, so don't worry about that. I've been doing and leading development teams for 10 plus years. I've been using Python since 2.3, which was like 2002, 3-ish, I think. And then Stack Overflow. I've basically been using it since it started. I don't know if any of you actually know the history of it, but they actually started doing a podcast, and in the podcast they were building it. And I happen to be probably one of the few people who were listening to that podcast while they were building it. So I got in early and just answered a lot of questions early on, so my score is a little high. All right, so data science in Python, it's really big right now. People using pandas here? Okay, and NumPy people? All right, good. So I think you probably know this. They have about a 10-year history for these two tools. And if you're all using it, I probably don't need to tell you what's good about it. But you can really cut down all your looping and whatnot. You can do vectorized operations on your data. It makes things so easy. Everything is there to love. So we have a big data science party, right? You having fun? Yeah? All right, but we got a big data stuff is growing, right? So back when NumPy and Pandas started, it was about 2007, 2008-ish. The data wasn't so big then. It's 2017 now. We're up 1,400% or something. This is just rough estimate, but it's not going to go down anytime soon. So if you're using Pandas and NumPy, you're going to have some memory problems maybe if you're running locally, right? Memory problems? No? You don't have that? Yeah. So, I mean, I've prayed myself that a process finishes and I can watch the swap space going up and up and up and up and just like, oh, just please finish. But then you hit the memory, all right? Not fun. And then, of course, you're doing the swap, so it takes extra time to do that. All right, so we have Dask. Anyone heard of Dask? Okay. Using it, you probably know it better than I do, if you're using it. I'm just here to introduce, hopefully, more people to it. Problem solved. Kinda. Let me talk about it a little bit. So today, I want to at least explain a little bit what Dask is. I'm just going to touch on the collections that it uses, the data types it uses, and I'm going to mainly focus on Dask distributed. From what I understand, there's single and distributed. I don't think you really need to worry about that too much. I'm going to try to demo what Dask does, a little live demo. We'll see how that goes. And then what I really wanted to talk about today, and I'm not going to get into as much detail as I would have liked, is how to run Dask in the cloud. I don't know if you've Dask people. If you know Dask, you probably watched Matt Rockland's talks on YouTube. I have several times. They're great. He magically has clusters available like all the time. I don't know if you watch them. And so, yes. So you'll see something today. It'll run a little slower than his demos. I'm just using this little guy over here. Yeah, so he has these lovely clusters available with hundreds and hundreds of CPUs. It's beautiful. I'm just going to kind of introduce how you can potentially run Dask in the cloud, hopefully. All right, so just a little refresher before we get into Dask. Pandas and NumPy, the basic components are a square and a cube. No, not a square and a cube, sorry. I want you to just use your imagination for a moment. This is a data frame. Data frame's like a 2D array, like a table. And the one on the left is a NumPy array, 3D n-dimensional array. So basically you can put tons of stuff in there. This is great, right? But this alone, we have memory issues. So what is Dask? Dask makes it super easy to make use of multiple cores on your machine. It will distribute that, take care of all the crap that you don't want to worry about. So basically, anything that doesn't fit in the memory, it will break it out, split it, and run it. Does that make sense? I hope so. Okay, let me try to explain a little bit. So you have a big server. Now I don't know, I worked in enterprise, and in enterprise previously, in my previous job, and in enterprise we didn't use the cloud too much. So if you had a big workload that you need to do, you would go to your manager and say, you know, I really need a huge server. Otherwise I need a lot of time, development time, and I don't think we have enough time. So then we'd go through an approval process, and we'd procure this lovely server, and checking with the data center, make sure it fits in there, make sure we have all the power requirements. And then you go and run your code. This is HTOP. I don't know if you're familiar with HTOP. And you're using 100% of one core, right? All right. Crap, I just bought a huge machine. All right, so we know Python, right? We can take care of this. So we have multiprocessing. It can take care of this, right? That's not too bad. We got multiprocessing. We just take all the data. We fan it out across all the processors. Not a problem. So you get something like this. You take each load, you split it out into arguments, and you split it out across processes, and then at the end you can do a sum on the data or something like that. Something really simple, right? Not a problem. But then, you know, your boss comes along and says, nah, maybe you want to group by something else. Oh crap, well then you're not really sure what you got to do. Why didn't you tell me that before? All right. So that's where Dask is really useful. Yes, you can use multiprocessing, but multiprocessing, you're going to have to handle a lot of the stuff Dask has been built to take care of for you, okay? So, just to back up and go to the basic components of the data frame and the NumPy array from pandas. What Dask does automatically for you practically, is it will break those up. So it manages multiple pandas data frames, all right? Or multiple NumPy arrays. And it will manage and schedule where that work should be done across your cluster. So you end up with a cluster, something like this. This is a simplified example. So basically, Dask runs with a scheduler, and you access the scheduler with a client. This could just be your Python script locally on your machine. It could be a Jupyter notebook. You interface with the scheduler, and then multiple workers will connect. The schedule will take on your job from the client and fan it out across all your workers. It's really nice. So, all right, well, we have Spark for that, right? Well, Spark's good. Spark's good, especially if you're in the enterprise. It's well supported in the enterprise. Hortonworks, there's lots of companies that have solutions based on Spark and can give you support on Spark. I think so. It provides a lot of operations. It also has an SQL interface, which is very useful. You can just kind of feed that to somebody. And it supports more use cases than simple map or multiprocessing, like I said. The problem, I don't know if you've actually installed a Spark or tried to get a Spark cluster running, but I have. And getting all that JVM installed and Mesos or whatever you want to do to run it installed and running properly is quite a pain in the butt. And now, this is Matt Rockland's comment. I wasn't really clear on, I'm not real familiar with Spark, so I don't really understand the difference there. But one of the things he mentioned was that it's not as good at arbitrary complex tasks, at building task graph around that. So for Dask, like I said, supports complex task graphs. It basically can handle a lot of what you would normally write in Python, okay? It's Python native. You don't have a lot of installation to do. You could install it now, right on your PC, pip install Dask complete. It will install everything you need. And then it will also have two tools, scheduler, worker, and you just run those as command line tools, and you can run it locally. Very easy. Now, cloud is a little bit different, so we'll talk about that later. But locally, if you have a local on-premise system, very, very simple to set up, very easy to get going. And like I said, it's NumPy and Pandas compliant. It operates on a subset of the NumPy and Panda APIs. So if you're using those tools already, it's really a great match for that, as opposed to trying to transfer your code over to Spark and support the Spark data frame API. The one problem that I'm sure Continuum can take care of is it's not widely supported, but I'm sure they have solutions, so you can talk to them. All right. Let's see if I can do this. All right, I gotta close this. I'm gonna try to get this set up. All right, so this is kind of hard to do. Can I use this? Thank you, thank you. Okay, am I in my window? All right, so just to explain, I have this nice razor blade 2017 I got for my birthday. It's running the scheduler and a worker. This has 8 cores, 16 gig of RAM. So this is a little stronger than my little Mac here. So I'm using this as the scheduler and the master node. So as I mentioned, when you install Dask complete from pip, you get Dask scheduler. So I'll just go Dask. I'm not going to run this here, but you would just type that, Dask scheduler. It would boot up the scheduler and give you, let me just do it once, see what happens here. Yeah, I'm already using it. Sorry about that. So, okay, so schedule. Let me just start a worker then. So Dask worker. And what I want to do is to connect to my guy over here. So I need his IP, which is 192.168. I have the IP over here, 121. Where'd he go? 8786. All right, so he is now connecting to my scheduler over here and registered. Now the scheduler, when you boot it up, provides an interface you can connect to, obviously, but then also as optional, you can install Bokeh. If you're familiar with Bokeh, it does a lot of live plotting, and you'll get this interface on another port. So this provides live Bokeh updates, and I should see now I have my 8-core machine over here is a worker registered, and then I also have my 4-core little Mac guy over here with puny 8 gig running and connected as well. So now I've got my 2 workers connected, and then what I'm going to do is from Jupyter Notebook, I'm going to attach this client. And so what I've done, it's telling me I have a dashboard available, which I have open over here. And the scheduler, it's telling me what is on there as well. And so what I'm going to do now is run this. Now, that looked like it ran really fast, right? So one of the things about Dask is it's very similar to PySpark or TensorFlow, if you're familiar. What it will do, it will first calculate the computation graph, or I guess in Airflow, the DAG will be prepared before you actually run anything. So if I want to actually run something, this is just an object to maintain all the necessary state information and information about the task graph. If I actually want to run it, I have to then run compute on this resulting object. Now, in addition, what I think is very interesting, you can actually see the task graph here. So if .dask, you actually get the resulting, can't scroll down. Come on, there we go. So you actually get the resulting task graph here in display, and it also has a good feature to visualize the task graph. Now, this simple, while simple, is very complex task graph. So it's so huge it doesn't make sense to display it. I'm sorry, I should have got a better example. Let me get down. Come on. And I'm using the New York City taxi data set that Matt Rothman uses quite a bit. I'm just going to show you a couple. Gotta kill this. Where's my? So big. Where's my menu? Sorry, I'm not used to this size. Come on. There we go. There we go. All right, so that was the task graph. And then if you want to actually compute it, we call compute on it. And what it will do, it will take the graph, send it off to the scheduler. If you look on the right now, you'll see that it's actually working. This is showing the worker cores that are registered with the scheduler. And so what's going on is the scheduler is fanning out the tasks, chunking up the data, and telling the workers what to do. Now, what is kind of tricky here, and something that Matt Rockland doesn't talk too much about, because he uses S3 in his examples. I'm using this on a local system, so what you have to do is you have to have either a shared network drive or the same data in the same location on both these PCs. So that's something you have to be aware of. And I think if you were going to set up a local on-premise cluster like this, you probably want to have an NFS or something like that where you could just share the data. So where did it jump back for? So it's calculating, and like I said, I don't have this massive cluster, so it takes a little longer than his demo does. What happened? Come on. So if it should be about done. Jeez. Okay, so we got the output here. Took about a minute to run that. And then that is was a sum of passenger counts across not all, but a portion of the New York City taxi data. Each of these CSV files is about 2 gig each, and when that expands into a data frame, it's a little bigger. So I was able to manipulate over, I think, about 10, 20 gigs of data just now in about a minute on this data. And then that was a simple sum. Here's a group by operation, and again, since I don't have a massive cluster, this is going to take a lot longer than it would in his fancy demos. But it should be, did I not run the cell? Didn't run it. So I'll go, oh, okay. So yeah, it's giving me the operation, and then I just have to compute it. So I compute it, and it sends it out to the scheduler, and the scheduler, again, will fan out the tasks as Panda data frames to each of the workers and with the data, and compute the result. Now this takes a little longer, so I'll just kind of let this run a little bit. Now the next thing I want to talk about here, and I just go back to my slides now. So this is a group by. It's going to group counts, I forget what it is, by distance, I believe. So this runs, it takes a little longer than the sum, but it will go out and fan out and get the results back, and you get a nice little dictionary of that result. So since that takes time, I'm just going to go ahead and skip ahead to talk about how you would do this on AWS. Okay, so we have a lot of people here using AWS. You probably know it better than I do. So I'm a bit of a beginner. Like I said, I was in enterprise before. We didn't use a lot of cloud. And so it's hard. This is a little bit of a startup for me to understand what's going on. Now, Dask has a number of different projects or tools that you can use to run Dask in the cloud in some ways. It has Kubernetes one, it has this EC2 project that does this. It also has a bunch of others as well. So if you're looking for an option, there are others. This is probably one of the easiest ones to get started with, since if you know Amazon, you can kind of step in and just, I think this is a pip install as well. You just pip install this right here. Go ahead and pip or conda install this, and you can get started right away. The thing I had trouble with setting this up was that I'm using US West 2 mostly, as it's a little cheaper. The default AMI that's in this Dask EC2 project is in the East, so you're gonna have to take it, copy it, use the AWS CLI commands or the console, copy that to the region. And then the other thing is there's a little bit of bug, it's an issue in this, you have to pass this tags argument to it, okay? And then also what happens is it will go and create this cluster for you, but then you're gonna wanna destroy this cluster when you're done. It's gonna take a bit of a cost here. It's got a pretty high AMI that it uses, or what is it, instance that it uses. So make sure you leave the file flag there, and you'll get the cluster information, and so it will be easier to destroy that when we're done. All right, so yeah, Amazon's really easy, right? Lots of stuff going on. So just to explain briefly, I really recommend using this Amazon CLI. It's great, unless you really like poking around and trying to figure out where they hide the things in the UI, and the UI tends to change. I really recommend the CLI, it's great. So install that. You want to upload your data to S3, and then start the Dask. The thing is, it takes about 10 minutes to get started, so I was planning initially to do everything live here and say, okay, this is how you set it up in the cloud, but it just takes too long. So I'm gonna skip and just kind of show you an image of what's going on. So once you have that set up, you can attach a web UI and schedule and get going. And then, like I said, don't forget to shut it down when you're done. All right, so these are just the brief steps. If you're not familiar with Amazon, this is just a little thing you have to do. You have to go and log in your Amazon, get your Amazon ID set up. Their CLI is a little bit later, but you need to set up your user groups and permissions to be able to do this. Install the AWS CLI, configure it with your access keys. And in today's example, and Matt's example as well, this New York City data is used. So you can pull that down and then go ahead and push it to a bucket. So this is creating the bucket. Oh, that's an old command, sorry. Creating the bucket via the CLI and then copying the data from your local PC to the S3. And then this is the setup for the Dask EC2 project. I'm using a virtual env. I create a virtual env here. I have a spelling here. Virtual env here. I activate it, and then I'm going to go ahead and just pip install it. Comes right in. And then what you want to do once you have it pipped installed, you are going to go ahead and run that. Now, for someone like me who's not familiar with Amazon, one thing you have to do is you have to set up your keys for this. I have a memo up there that I missed, but you have to set up your private public keys before you can do that, and that's what these key pair and key name are. Set your regions, and like I said, I had to copy the AMI from the east to the west manually, and then once you get that, something like this will happen for about 10 or 15 minutes, and it will run. And then you'll have your EC2 up, and then don't forget to destroy it. So it's relatively easy to get this up and going in the cloud. Like I said, this EC2 method uses the EC2 instances. And so one of the things is it has to spin up the instance in the cloud and then install everything. So one of the things I would really like to do, and I know there are some projects on that, is to use Docker. Docker would then provide a pretty much set up environment already, and you could be able to deploy that a little easier. So this is something I'm hoping to look into. There are projects, there's Kubernetes as well, that do this. I'm a little more familiar with Amazon, so what I would like to do as a next step is to set up workers, at least, maybe spin up a single scheduler as an EC2 instance, and then have an auto-scaled cluster of workers in the cloud. So when you'd have that, you could just set your auto-scaling group to a single worker, and then monitor the memory, or you could monitor the CPU usage, so then it could auto-scale up to a maximum defined number of workers. So that's my next step. Maybe next year I can show that. All right, so any other alternatives to Dask? Well, not, like I said, there's Spark is probably the closest in terms of processing, but I think you may be familiar with Airflow. Celery is like a task processor, and Luigi is also like a data pipeline manager. Also, I'm not sure if you've heard of it, but Pyren is very interesting for distributing data processing tasks. What this does is a project that is like a simple map function that you can farm out to AWS Lambda. So you can take your Python function, use Pyren, and it can just spin that out to thousands of cores of PC. So it's very interesting. Lightweight, doesn't have the power of Dask, but it's very interesting. All right, so that's all I have for my presentation. Thank you very much.
Alrighty, thanks Shane. We have a little bit of time for questions. Does anybody have a question?
Thank you for your, and I have two questions. And first, I know that Abijah uses Spark 2. What is for what using Dask, and for what using Spark in Abijah?
So yeah, Abijah is a company I work with. We do have data processing solutions that use Spark in production. We currently do not use Dask in production. This is just something I'm investigating, more of a personal interest.
Small processing to Dask is for small processing, and Spark is for large. Sorry.
No, it's okay. No, so I don't think there's a big difference between what you can do with Dask and Spark, at least what we do. We use Spark with S3, so it wouldn't be too much of a difference there. We do use some data structure like Parquet and stuff with S3, but it shouldn't be too much of a difference, I think. Parquet, Dask supports that as well, so.
At your slide, there are the sentence, Abijah not able to handle very complex computations at Spark. What is the mean?
I'm not real too familiar with Spark, but I'm guessing that the intention of that statement is it can't do as diverse task graphs as Dask can handle. Does that make sense? Maybe.
If I could offer just a little bit more color to that, the general idea is that Spark's model of computation has a map, and then a filter, and then a reduction. And so all processing becomes that way. Dask, of course, can do that as well, but because the Dask graph is arbitrary, you can have very complicated things that happen in the middle. You can have a map, and then depending on the needs of the algorithm, some things filter, but some things may reduce right there and map into more things and do all these things. And so there are some Dask graphs that become very complicated. They almost become unrenderable, but you only have 3 lines of a pandas or a Python or a NumPy expression, but the actual underlying what has to happen to all the fragments of your data can become this very complicated mess of things. You never have to look at it. The scheduler still processes it, but you would never be able to do that natively in something like Spark, or it would be much less efficient. You'd have a lot of intermediates, right back to the RDD that would have to happen. So that's why for something like the scientific world, Dask is a much better suited thing for a lot of the scientific algorithms, versus Spark is much more designed for business data processing pipelines.
All right, fantastic. I'm sorry, I'm going to have to end it there. We're a little bit out of time, but lunch is coming up, so I'm sure you can continue the discussion over lunch. Let's thank Shane once again.
Thank you.